Hello guys, so in this video what we're gonna do, we're gonna look at formal hypothesis test for correlation. And at the beginning of the class, of the course, we were talking about linear correlation, so you're already familiar with this topic. And the linear correlation explores basically the relationship linear, or whether there is a linear relationship between two quantitative variables. One variable is x and one is y, and we look at the relationship between those two variables. Again, with just remember that with linear correlation, we can only prove correlation and not a cause and effect relationship. So this is a limitation of this test. You cannot prove that one variable causes changes in the other variable. But in your final project, you will be asked to compare two variables, and that's one of the options that you will have. Just see if there is a correlation between two numeric variables. So let's start formal hypothesis test. So first, what I'm gonna do, I'm gonna walk you through the steps of this hypothesis test, and then next we're gonna look at the example. Okay, so this hypothesis test, we're gonna test whether there is significant correlation between the variables. Okay, so we denote the population correlation coefficient with a Greek letter rho. And this rho is a correlation coefficient for population. All right. Now let's talk about test components. Test components. So for hypothesis test, we need the null hypothesis, and our null hypothesis will say rho is equals to 0. So which means no linear correlation. No linear correlation exists between two variables. Okay, now our alternative hypothesis will be rho is not equal to 0. So this is standard. You're not gonna, you have to decide whether it's less or greater than, or it's always going to be not equal to, which means the correlation exists. The correlation between x and y variables exists. Okay, so that's your null and alternative standard. Now let's talk about our test statistic and decision making. So your test statistic is gonna come from the table or the Statcrunch. So for now, I'm gonna ignore the test statistic. We're gonna jump straight for the p-value, and we're gonna using Statcrunch, and we're gonna compare it against our um, significance level, alpha, and then we're gonna do the same thing we always did. We're gonna make a decision and write a conclusion based on the p-value versus versus the alpha region or rejection region. Okay, so let's go ahead and so decision. Basically, we're gonna if p-value smaller than alpha, then we're gonna reject the null, and then if p-value is greater or equal to alpha, I think failed to reject the null. And then we're going to write the conclusion. So let's go ahead and actually take a look at one of the examples. So here's one of the examples. We have, ignore this, so we have an alpha of 0.05, so 95% confidence level. Okay, and it says the table below lists the numbers of audience impressions in hundreds of millions listening to songs, and the corresponding number of albums sold in hundreds of thousands. The number of audience impressions is a count of the number of times people have heard the song. Does it appear that album sales are affected very strongly by the number of audience impressions? Okay, so we have a list of audience impressions. So X is our control variable, and albums sold will be our response variable. Okay, so we want to see if there is a change in one variable, y variable, when x is changing, or in other words, does x affect y? So x is our control variable and y is our response variable. Okay, so question A, find the regression equation and the linear correlation coefficient. Determine if there is a linear correlation between the number of audience impressions and the number of albums sold. So we're gonna start by writing our null and alternative hypothesis. Null says rho equal to 0, so no correlation, and the alternative says it's not 0. Okay, so now the rest will be done using Statcrunch. So I'm gonna go there right now. Okay, so I'm in Statcrunch right now, and I entered my first variable. I'm gonna call it x, and because I'm lazy, you should write, what x is. It's audience impressions, and your y is number of albums sold. Okay, so you go to stats and summary stats, and you're gonna select correlation, and so your column X and Y. Keep control button to highlight both, and then you're gonna click on two-sided p-value, because we have a two-sided test click on compute, and it's gonna give you the correlation coefficient of 0.7959, and it also gives you the p-value right here. So it gives you the test statistic that's 0.7959 around it, and then it gives you the p-value, critical value, p-value of 0.0103, and our p-value is less than our alpha, less than 0.05. Our alpha was 0.05. So based on that, we're gonna reject the null. Okay, and accept the alternative, which says, so we reject the idea that there is no correlation, and we go with the H sub A version that says that there is a linear correlation. So let's see how we're going to phrase it. It says, does it appear that album sales are affected very strongly by the number of audience impressions? And we're going to say, yes, there is a linear correlation. Between the audience impression and the album sales. All right, guys, so I guess you don't see it. You don't see what I wrote. Here it is. Okay, so now the next question says, find the best predicted number of albums sold for a song with 100 million audience impressions. So in order to find the predicted value, we have to actually find the line, just like we did in previous parts, way back then. Let's go through this again using Statcrunch. So here we are. We will have to go to a different, we would have to go here to regression, select simple linear, and again, select your X variable and select your Y variable. And hit compute. So we're in hypothesis test. And here we have our equation. Our equation is y equals negative 10.665035 plus 1.16799. Okay, so let's write it down. I'm going to keep 3 decimal places. All right, X is here. Remember, our line is in the form B plus AX. All right, so and here we have our correlation coefficient again. It just repeats. And then we have R squared. And R squared, it's an interesting piece. It explains how much variation in the response variable changed due to change in the control variable. So about 63% of albums sold depended on number of audience impressions. And we could actually state it here. We can improve our conclusion a little bit by stating that. But this is not why we're here. We actually needed this equation, and now we can complete our question. It says we have an equation. Now we have a 100 million audience impressions. So X is 20, and we're going to put it into our formula. And let's see what we get. Okay, I got 12.705, 100,000, of course, albums sold based on this here, based on 20, what is it, 100 million audience impressions? I forgot. 100 of thousands, yeah. No, those the album, 100 of millions audience impressions, yeah. Okay, so hundred thousands. Of albums sold. All right, so this is how you compare two variables and test for linear correlation between two variables.